Hello, welcome all to Science Simplified Session 2. In Session 1, we learned about gravitation. We will now learn about characteristics of gravitational force and the effect of gravitational force, what we observe in day-to-day life. The gravitational force, the characteristics of this force are: the gravitational force is always attractive. Gravitational force cannot be shielded by any other object. Gravitational force acts even at infinite distance. Gravitational force never becomes zero. Gravitational force is an intrinsic property of all masses, and the gravitational force does not depend on the chemical composition or electrical charge of the object. Weight. This is the effect of gravitational force in everyday life. To understand the concept of weight, let us try to answer the following questions. Can you earn profit by selling gold on north and south poles? If Earth stops rotating, will your weight increase? How high can you jump on moon if you can jump 1 meter on Earth? To answer these questions, let us understand what is gravitational force and what happens due to the gravitational force. To understand this further, any force will always create acceleration in the body. The gravitational force is given by F equal to G into m1 m2 divided by r square, where m1 is the mass of the earth, m2 is the mass of an object, F is the gravitational force between the two objects, G is universal gravitational constant, and r is the distance between two objects. If we now recall the second law of Newton, whenever a force is applied on a body, it creates an acceleration in the body in the direction of the force, and it is given by mass into acceleration. So if we combine these two together, we get G into m1 m2 divided by r square is equal to m2 into a. Solving it further, we cancel m2 from both the sides of the equation and we get a equal to G m1 divided by r square. Hence, a is the acceleration in mass m2 due to Earth gravitational force. This is usually written as small g. Now we get the value of the small g as g into m1 divided by r square. Let us understand further the implication of this formula for acceleration due to gravity. As shown in the above formula, g, which is a universal gravitational constant, is a constant figure. m1 is the mass of the earth. R on the surface of the earth is the distance equal to radius of Earth. All these values of Earth are constant. This means G is also constant on the surface of Earth. This also shows that G is not dependent on the mass of a falling body. Thus, the velocity is same for all the falling bodies on Earth, irrespective of the mass of the falling body. This means that bodies of different masses falling from the same height will reach the ground at the same time because they have the same velocity. Now we shall see a video clip in which a cannonball, which is very heavy, and feathers are falling down from the same height. Please observe when they hit the ground, once in air and then in vacuum. This experiment was done in one of the nuclear reactor which is closed. In this reactor, there is a possibility to create a full vacuum. So first you observe that a heavy cannonball and feathers are released from the same height. You can easily observe that the cannonball has reached the ground first and then the feathers have come after it. This is because there is a air inside on which the feathers start floating, and that is why there is a air resistance to the feather and they reach the ground late. Now a full vacuum will be created inside and the same experiment will be repeated again. Now you can see that whole reactor is fully converted into vacuum to ensure that there is no air inside, and again the cannonball and the feathers will be released. Observe carefully. Now both cannonball and the feathers are coming down at the same speed. This is what we observed, that G is independent of the masses, and this is why both the feather and the cannonball hit the ground at the same time. So this proves that the velocity of a falling body is not dependent on the mass of the falling body. We have seen that value of G is constant at the surface of the earth. The value of G can be found by substituting capital G as 6.7 into 10 to the power of minus 11, mass of the earth as 6 into 10 to the power of 24 kg, and on the surface of the earth, the distance of any object from the center of the earth is 6,371 kilometers. If we now substitute these values, then we get the average value of G on the surface of earth as 9.8 meters per second square. We call it as average value because the radius of the earth is not uniform all over. At the poles, Earth is flattened, hence the radius is less than the equator, hence G is more. At equator, Earth is bulging, hence the radius is more, hence G is less. And at a height of a satellite or a spaceship orbiting Earth at 400 km above the surface of the Earth, G is further reduced. Now, what is weight? Weight of an object on Earth is the gravitational force exerted by Earth. The force is given by F is equal to ma, which is equal to mass into small g on Earth. Thus, the weight of an object changes as the value of g changes. Going back to the earlier table, we now find that the average weight on Earth of a mass 10 kg is 98 newtons. But on the pole, it will be higher, 98.3, because the value of G is more. The same mass of 10 kg will weigh 97.8 Newton on the equator because the radius is more and G is less. Whereas the weight inside the spaceship will be 87 Newton. From here, you will also see the weight of a body in the spaceship is not zero. It is never weightless. It only reduces the weight because the gravitational acceleration at the spaceship is much less. We will see in the next sessions then how we float inside the spaceship, how an object becomes weightless in the spaceship. Going further, we can calculate the value of G on the surface of various planets, and a mass weighing 75 kg on Earth will weigh only 28.4 kg on Mercury. On Jupiter, it will be highest, 189.8 kg. On Saturn, it will be less, etc. This is because of the change in value of G on the surface of the planets. But on Sun, we will weigh 2242 kg because the gravitational acceleration on Sun is very high, and on Moon it is very less, and a person weighing 75 kg on Earth will weigh 12.2 kg. Hope you have understood the effect of gravitation as weight, and even if the mass is same, the weight of the body keeps on changing. So let us get the answers to the initial questions. The first question is, can you earn profit by selling gold on North and South poles? You will see in this diagram, the weight on equator is less, whereas weight on poles is higher. Hence, you can buy gold on equator and sell it on North poles. The mass remaining same, the weight will be more. If Earth stops rotating, will your weight increase? In this diagram, because of the rotation of the Earth, there is a force outward acting on a mass. Hence, the net force is the gravitational force pulling down and the centrifugal force pushing you out. The difference between the two forces give rise to your weight. Now, if the earth starts rotating, the outward centrifugal force will become zero, and hence your weight will increase if earth starts rotating. How high can you jump on moon if you can jump 1 meter on earth? We have seen the value of g, small g being less. Your weight on moon is only 1/6 that of earth, and that is why you can jump 6 times higher than earth since your weight is less. So in all above, mass remains same, but weight keeps on changing. So this is the first effect of gravitational force. Thank you. We will see in future sessions further concepts as weightlessness and other. Thank you.